Hi dear students, good evening all of you. Good evening Shravani, Kirtika. Yes, Manishat, Fatima. Hi, Shivakumar, Harika. Good evening all of you. Have you gone through yesterday's class once again? Because today we are going to see relations, and for this you must know the basics. Set theory you should be thorough with, and that is a Cartesian product, and the function also you should know. I hope all of you are thorough with those things. Fifth chapter you have to start. Okay. Yeah, today we'll discuss. Okay, today maximum I'll try to complete. If you cooperate, I'll complete second unit. Okay. Next fourth or fifth you want. Yeah, fourth is very small. You can also study on your own because everything is available in the channel also. So fifth, okay. Graph theory. Good evening, Sagar, Mohan. Good evening, ma. Bhavya, sequence, you asked about sums and sequences. Actually, from in R18 till now, no question was asked in that topic, I think. That's why I didn't touch that. After completing, if time permits, we'll see that. Okay. Good evening, Shritika. So, we have completed 4 units. This is fifth class for second unit. So, for this Cartesian product, you must know. Okay, so first let me explain that. I'll give you one set. All of you please write the Cartesian product of the set. Okay. Let A is equal to, already we have studied these things, but just for recollecting. Let A is equal to 2 comma 3, B is equal to 3, 5, 7, and C is equal to some elements, any elements you can take. C is equal to 3, 5, 8. Okay. So prove that cross means it is Cartesian product. Okay. A cross B union C is equal to A cross B union A cross C. Try to do this, all of you. All of you please do this. Four and five. Okay. Uma, good evening, ma. 1, 4, 5. If we do, how much you can score? You can clear if you are thorough with those things. You can clear, Nazima. Good evening, Nandini. So first let us find out B union C. All of you know what is union and cross product also. So A union B union C is what? 3, 5 is common. 3, 5, 7, 8. Right? And A cross B union C. What is A? A is equal to 2 comma 3. Let us write in that order so that it will be easy for you to understand. So 2 comma 3 and B union C is equal to 3, 5, 7, 8. Okay, and A cross B union A cross. First, let us find out A cross. LHS is A cross B union C is equal to, you consider the one first element from the first set and take the pair with all the elements in the second set. Okay, then consider the second element and consider with the pair it with all the other elements in the second set. So 2 comma 3, 2 comma 5, 2 comma 7 and 2 comma 8. That is first element is over. Now it's going to the second element. So 3 comma 3, 3 comma 5, 3 7, 3 8. Okay. This is the Cartesian product of A with the set B union C. B union C. Next is A cross B. What is A cross B? A is 2 comma 3, B is 3 comma 5 comma 7. So it is 2 3, 2 5, 2 7 and 3 3, 3 5, 3 7. Right? This is A cross B. What is A cross C? A cross C is, here A is 2 comma 3 and C is 3 5 8. Right? So it is 2 3, then 2 5, 2 8 and 3 3, 3 5, 3 8. Now we have to take the union between these two sets, right? So A cross, let us take the first one as equation number 1 and second one. This is LHS, okay? And this is RHS. Right hand side is A cross B union A cross C is equal to, now union of these two sets. So first let us write all the elements from A cross B, that is 2 comma 3, 2 comma 5, 2 7, then 3 3, 3 5. Always remember, whenever you want to find out union, you write all the elements from the first set, then coming to the second set, now you have to write, if it is repeated, if it is already there, don't write it again, don't repeat the values, okay. So again 2 comma 3 already we have written, 2 comma 5 we have written, 2 8 it is there, no, only 2 7 is there, so 2 comma 8 you have to write, okay. 2 8 you have written. Now sorry, one more will be there. So 2 8 is not there, and check for every element. 3 3 is there, 3 5 is already there, 3 8 is not there. So 3 8. Got it? So now from 1 and 2 we know that LHS is equal to RHS. They are equal. They are equal. They have to be equal. You are asked to prove that they are equal. You have to find out. You have to show that both the sets are having the same number of elements and same elements also. Not only number, same elements also. Okay. Yes. 2 comma 3, 2 comma 5, 2 7, 2 8. It is there. 3 3, 3 5, 3 7, 3 8. Okay. Yes. Excellent. Excellent. Very good. Very good, ma. Please write in the symbol, okay, with in the exam. Maybe for typing it may be difficult. Yes, exactly. Very good. So all of you understood. This is what is Cartesian product. Cartesian product means if you have two sets, no, then you have to write all the elements. Now we are going to define the relation. A relation can be thought of as a structure that represents the relationship of elements of a set to the elements of another set. Can you give some real life examples from relations? Relations. If you have brother and sister, it is also a relation. It is if you have a pair of brothers and sisters, okay. It is a set. Yes, it is a relationship. Okay, brother and sister. Yes, anything else? Mother, child. You can say teacher and student also, no. You are, because we have so many students, okay. If the teacher is working in a college, all the students in the whole state, all the students need not be the student of same teacher, right? But if you are a student, then they are related. If the teacher is teaching this particular student, then they are related. Like that, you can define the relation. Okay. These are all examples of relations. See, in the world we have so many of people, lakhs of people are there, but we don't know all individually, right? So if we have some relationship, then we can mention that is a relationship. Like this, two elements if you consider, if they are related, we should have some condition, right? So binary relation, always you remember binary relation will be a subset of the Cartesian product A cross B. When A and B are two sets, a subset capital R of the Cartesian product A cross B is called the binary relation. We have two sets, that's why it is binary relation. Okay, if R is a binary relation from A to B, then R is a set of ordered pairs A comma B where A belongs to A and B belongs to B. Okay. Yes, HR and employees. Yes, very good, very good. Good example. Good evening, Navanita. Yes, ma. Yes. So, if R is a binary relation from A to B, R is a set of ordered pairs A comma B. Okay. And generally we write if A and B are, if A comma B belongs to R means what? A is related to B. Generally we write like this. A is related to B. And if they are not related, then R should be crossed like this. Okay. You have to strike off that R. They are not related. This is the notation, right? If you write A or B, then it means that A is related to B. Or in other words, you can write A comma B belongs to the set capital R. Always please remember R is a subset of the Cartesian product A comma B. If you have binary, if you have two sets, then and already we have seen one example for A cross B cross C. Okay, so it is trinary and so on. Okay, you need not worry about that. We have that is also there, but till now we have not asked questions in that. So let us see. We will see towards the end. Okay, the other relations. So if let us now study, be thorough with the binary relations. Okay, if R is a relation from a set to itself, that is R is a subset of A cross A. Subset to itself means what? A cross A. Then R is called a relation on the set A. Please remember, if it is mentioned that on the set or in the set, then it means that it is the function is from A cross A to, it is defined on A cross A only. Okay. So the set, that is both the elements are from A. Both the elements are from the same set. Yeah, definitions are also important, Uma. All the definitions are important. Yes, yes, of course. Generally, relations they will ask. Okay, they may not ask define a function and all, but don't know. We can't say. We can't say. So better to be thorough with the definitions also. Definitely, you can expect this equivalence relation, partial ordered set. All those things are very very important. You can definitely. These are all standard questions. Okay. But these definitions also can be expected. Okay, so better to be thorough with the definitions. If you understand, no, you can write on your own words, no problem. If you understand the definitions, then you can write. Okay, so the set A belongs to A such that A is related to B for some B is called the domain of R and denoted by D of R. Domain of the function. Already I have told you, we have seen in the previous class, this is the domain. If the function is defined from A to another set B, F is defined from A to B, then when we see that fifth unit, we will see that no. Now let us concentrate. Don't keep on thinking about other things. See, simultaneously, if you are concentrating on here, you won't be. If you are thinking of the fifth unit, no, you won't be able to concentrate on second unit also. Now, see, at a time, simultaneously, don't think of two units and all. Now, if you want to study these things, no, please concentrate only on this. After finishing this, we'll go to anyway, fifth unit we'll see. That time we'll see. Don't worry. Okay. That time I'll explain everything. And if I explain, if you listen to my class, definitely I can assure you that I'll make you understand. and please understand the concepts so that it will be very easy. Any problems can be answered. You will be in a position to answer any question. Okay, if you understand the concepts. That's why I never ask you to by heart things. Certain formulas, of course, you have to write, like implications and all. Okay, don't worry about the other things. Now you concentrate only on this, right? Yes. Yeah, A is the domain, B is codomain. Yes, ma. So what is range? What is the difference between codomain and range? Anyone? Here, this is again the definition. Set of all B belongs to B. A is related to B for some A in A is called the range of R and is denoted by R of R. Yes. What is the difference between? Now Shrutika told that this is codomain. Correct. Very good. This is domain and this is codomain. What is the difference between codomain and range? What is the difference between codomain and range? Are they equal always? Are they equal, Shravani? Range means only images. Yes, yes. What is the, yes, very good, excellent. Range is a subset of codomain. Range is a subset of codomain. Range is a subset of codomain, okay. It may be equal, sometimes it may be equal. If it is onto, definitely they will be equal, okay. Yes, images, range is only images and codomain is the second set, okay. Yes, okay. Now types of relations, we have some more definitions. A relation R on a set is called universal relation if R is equal to, that is if it is not the subset, if R contains all the elements of the Cartesian product, then there is a name for that relation, it is called universal relation. From the name itself you can remember easily. Universal means what? Everything. You have to consider everything. Okay. Yeah, they may be equal, they may not be equal. Yes, definitely. If it is onto, they will be equal. If it is onto, then they will be equal. Okay. Otherwise, need not be. Okay. Uma. Yes. Now, a relation is called universal relation if R is a subset of A cross A. R is a subset of A cross A. Sorry, it is equal to A cross. Generally, I told you, R will be a subset of A cross A. Sometimes it may be equal also. Vamshi, definitely I'll give you notes. Don't worry. Yeah, yeah. Yes, ma. Actually, I have to make that PDF. That's why. Okay. Yes, they may not be equal. Yes. Okay. Yes, ma. Yes. Hi, Poonam. Poonam Kamath. Next is, for example, if A is equal to 1, 2, 3, then R is equal to A cross A. A cross A is what? All the elements. It is 1, 2, 3 to 1, 2, 3. Cross product with 1, 2, 3. Okay, from 1, 2, 3 to 1, 2, 3. Okay. On to, no, on to, Shivakumar, that means you have not gone through the previous classes, right? 1 to 1 is injection, injective, okay, and onto is surjective. Bijective means one to one and onto, both. Then it is bijection, okay. So now this is the universal relation. This is the example. Next is a relation R on a set is called void relation or null relation. When if R is the null set, that is if there is no element in that relation, there is no element which is having the relation, then we say that it is void relation. Void relation. Okay. You have to see if you are going for a second part of a movie, then part 2 if it releases, you must see the first part, right? Without knowing that continuity, how will you understand the second part of the movie? Will you ever do that? No. Only for our classes we are doing like that. That is why you people are feeling maths is difficult, because we are taking everything for light, no, right? Isn't it? Anyway, next day we can study like that. Don't be like that. Be what to say? You must have concentration. You must have concentration, and you should put little effort. See, I am putting lot of effort to make you understand. You should also put little effort. Again, once you please go through that so that you will understand the concept. Okay. If you understand the concept, definitely you will be able to answer any question. Any question. Okay. Yes. Yeah. Injection is 1 to 1. Yes, ma. DM is not at all hard subject. It is very, very easy subject. Sharif Sheikh. If you feel, please remove that block from your mind, no? Surjection is, Nandini, it is, yes, ma'am. Okay. So, a relation R on a set is void relation if there is no element in the relation. For example, if A is 3, 4, 5, A is a set which contains 3, 4, 5, R is defined as A is related to B if and only if A plus B is greater than 10. That means A plus B, any possibility? There are two elements, no? 3 plus 4 is 7, 4 plus 5, 9, 3 plus 5, 8. Maximum it can be 8 only, right? 9 only. Yeah, 9 only. 4 plus 5, 9. So it cannot be greater than 10. So you cannot find out any elements A and B such that A is related to B. That is A plus B is greater than 10. Then definitely you will get this as empty set only. There is no element which satisfies this condition A plus B greater than 10. That is why it is empty. Okay, that is called void relation or null relation, void relation you can see. Now identity relation, yesterday we have seen one problem, right? In identity relation, a relation R on a set is called. Always please remember, I insist on this, on a set means it is a subset of A cross A. If it is defined on a set A means R is a subset of A cross A. Please remember that. Please remember that. Okay. So if A comma A it belongs to this, wherever for all A in capital A and is denoted by IA, identity relation on the set A. Identity relation on the set, that is A comma A is related to A. All the values, for all the values A comma A should be in A. Okay. We'll see some example. If A is equal to A comma B comma C, if A is equal to capital A contains three elements A comma B comma C, not dot, it is a comma. Then R is equal to, see, for all the elements it should be related to, it is like reflexive. It is also called reflexive. We'll see the relation in that. Okay. So if A is equal to A comma B comma C, R is equal to A comma A, B comma B and C comma C is the identity relation on A. Okay. This is an example. See, for all the elements, it should be related to itself. A comma A, if C comma C is not there, it is not called identity relation. If one is missing also, we don't give that name. Okay. Next is inverse. If when R is a relation from set A to set B, then inverse of R is denoted by R inverse is the relation from B to A. See, F is R is from A to B means always, as we have seen in the function, the same thing. R inverse will be from B to A. Okay. From B to A, which consists of ordered pairs got by interchanging the elements of the ordered pairs in R. And here A comma B belongs to R means B comma A will be there in R inverse. Just invert these, interchange these values. That's all. Okay. That is, if A is related to B, then B R inverse B is related to A is related to B by the relation capital R. Then B is related to A by the relation R inverse. Okay. And the complement of R is denoted by R bar is denoted by, actually if you write R union R bar is equal to, you must get the same set. Okay. Whatever is not there from R, you have to take that. I told you R is a subset of A cross A, and subset means what? Some elements are missing. Then R bar will be A cross A minus R. Okay. Or you can say R bar is defined by A cross A minus R. Okay. Next is composition of relations. Already we have seen composition of functions. It is also almost the same if R is the relation from a set A to set B and S is a relation from a set B to set C. Then R is a subset of A cross B, we know. S is a subset of B cross C. See, R is the relation R is the relation from A to B. Here it is. written already. R is the relation from A to B. S is the relation from B to C, right? Then the composition of R and S denoted by R composition S is defined by R composition S means what? R of S of S, right? So it is A comma C there exists such that there exists some B belongs to capital B such that A comma B belongs to R and B comma C belongs to S. Okay. Now properties of relations very important. You can expect one definite question from these properties of, unless otherwise you understand these properties of relations, you cannot do equivalence relation, you cannot do partial ordering. Okay. So properties of relations is very important, and throughout these topics it is all these properties will be used. So a relation R on a set A is said to be reflexive. See, try to understand from the name itself. Reflexive means what? You must have the same value, right? So A is related to A for all A in E. A comma A, this should be identity relation. If you have only these values, it is identity. Along with this, you must have some other, you can have other topics also. Okay. So A is related to A, and for all the elements of A is related to A. Okay. And A is equal to 1 comma 2 comma 3. See, what is the difference between this IA and this set? Now we say that it is reflexive, right? One is related to 1. First let us see whether it is reflexive or not. Yes. 1 is related to 1, 2 is related to 2, 3 is related to 3. There are 3 elements in the set A. There are 3 elements in the set A, and each element is related to itself. Okay. What is the, just now we have seen one identity relation, no? What is the difference between identity relation and this relation? Identity relation consists of only these 3. 1 comma 1, 2 comma 2, 3 comma 3. Only these 3 elements are there in that set. Okay. That is identity relation. Now along with that you can have some other elements also. Okay. Now, but all the elements should be related to itself. 1 comma 1, 2 comma 2 and 3 comma 3 should be there in the set. Then it is called reflexive. Okay. Okay, you are not able, if you don't understand anything, tell me, I'll explain again, don't worry. Because I thought I'll complete today these relations and Hazy diagram. If we complete, tomorrow we can start the 4th or 5th unit. Okay, that's why I thought. Otherwise, one more class I'll take, no problem for me. Did you understand or not till now? Any doubts? Any doubts? If you have any doubts, tell me. Yes, ma. Shall I proceed or not? Did you understand? Because this is very important. Definite question you can expect even the previous question paper. And I want to tell you, I have solved that paper Saturday. Supplementary exam was there on 24th. That question I have posted in the channel and with answers also. Answers also I have uploaded. Go slow, okay. Reflexive onwards, I'll explain again. Okay. See, already these are all very easy only. That's why I'm going little fast. Okay. And it is there. If you want to make it more clear, these topics are already available in the channel. You can go through again. Okay. Yeah. From reflexive, be attentive. This I'll go slow. Okay. From reflexive onwards, because all the other things are easier only. Right, up to composition of relations, whatever we have studied only, right? Now, okay, reflexive means what? Every element of the set should be related to itself. So 1 comma what? For example, if I consider the set A is equal to 1, 2, 3, R is the relation. This is the relation, defined relation. It contains 1 comma 1, 1 comma 2, 2 comma 2, 1 comma 3, 2 comma 3, 3 comma 3, right? Now, whether it is reflexive or not, how will you find out? 1 is related to 1. See, every element should be related to itself. Okay. Yeah, this is types of types of relations. Types of relations I have completed, Noma. You please go through again. If you get any doubt, please post it. I'll explain again. Okay. In that I'll answer. Don't worry. Right? Whatever doubts, whichever is not clear, you tell me. I will explain those things. Right? And now R is equal to, this is the relation. If you want to find out whether it is reflexive or not, how will you find out? Here we have three elements, 1, 2 and 3. One should be related to itself, that is 1, 1. Whether it is present in R or not, you find out. Right? 1, 1. Next element is 2, right? 2, 2 should be there. 2 should be related to itself. So 2, 2 is there or not? Yes, it is there. Okay. Then for 3 also. 3, 3 should be there. You have to check whether it is available in the relation or not. So 3, 3. So 1, 1 is there, 2, 2 is there, 3, 3 is also there. Therefore, R is reflexive. Clear? Clear? Along with that, you can have other elements also, no problem. Right? Next is irreflexive. Irreflexive means what? If one element is not related also, it is irreflexive. Okay. It is not, please understand, try to understand that a relation on a set is irreflexive. For every A belongs to R, A comma A does not belong. It should not be related to itself. It should not be related to itself. Okay. For 1, 2, 3, 4, you can find out relations like that. No problem, you can. Okay, if you want to find out whether it is reflexive or not, 1 should be related to 1, 2 should be related to 2, 3 is not there, so it is not reflexive. You can find out the relations like this. 1, 2, 3, 4 also, no problem. You can find out the relations. Okay. So now, for every A belongs to R, A comma A should not be there in the relation. Every element should not be related to itself, then it is called irreflexive. So now I will get a doubt whether if it is not reflexive, what is the condition for reflexive? Every element should be related to itself. Every element should be related to itself, right? And for irreflexive, every element should not be related to itself. You should not have 1, 1. You are not supposed to have 2, 2. You are not supposed to have 3, 3. So, if it is not reflexive, can you say that it is irreflexive? No. You cannot say like that. See, if it is not reflexive, irreflexive does not mean that not reflexive. Not reflexive is different from irreflexive. Irreflexive means no element should be related to itself. Got it? No element should be related to itself. For every A comma R, A comma A should not be there in R. Okay. Now I will give you example, you will understand. A is the set 1, 2, 3. If I consider this relation capital R, 1, 1 is there, 1, 2 is there, 1, 3, 2, 3. Will you say that it is it reflexive first of all? Is it reflexive? One is reflexive means what? You must have all the elements related to itself, right? So 1 should be related to itself. So 1, 1 should be there. Yes, of course it is there. 2, 2 should be there, which is not available. Therefore, it is not reflexive. Right. Now, can you say that it is irreflexive? No, it is not irreflexive also, because you are not supposed to have this 1, 1 if you want to take this, it is irreflexive. Okay. You are not supposed, no element should be related to itself. You are not supposed to have 1, 1. For reflexive, all the elements should be related to themselves, and for irreflexive, no element should be related to itself. Understood the difference now? So, there are some relation. Please note that it is not the, wait. If the relation is not reflexive, it need not be irreflexive. It need not be irreflexive. For example, this is the example. This is the example for this note. Okay, R is 1, 1. It is neither reflexive nor irreflexive. Got the point now? So, irreflexive means don't assume that if it is not reflexive, it is irreflexive. Okay. Why to divide this 1, 2, 3? Why to divide, Lucky Rail? How to divide this? Why to divide? What is the need? It is just example, ma. It is just example. 1, 2, 3 is the set I have considered. You can consider any set, okay? And this is a example relation only. It need not be always like this. You can take your own examples, no problem. Got it? But it should satisfy the conditions, that's all. Okay? Next is symmetric. Symmetric. Symmetric means what? It should reflect the other side, okay? Reflexive means same. Reflexive means same. Okay, so A should be related to itself. That is reflexive. From the name, try to remember. Symmetric means what? If it is available in the left hand side, it should be available in the right hand side also. You need not divide any set, ma. Any set you need not worry about that. These are all examples only. Even in the exam, they will not ask you to divide and all. They will give some sets, you will be asked to find out. They will give the set, they will give the relation, everything, and they will define the relation. You will be asked to find out whether it is reflexive or symmetric. We'll see problems in that, don't worry. Okay, when you do the problems, you will be able to understand. Got it? Now, symmetric, a relation capital R on a set. Okay, Bhavya, you are writing the sets, okay, for what? For what? You give some examples, I think, no? Yes. Okay, so a relation R on a set is symmetric if whenever A is it divided? Why is it divided? It need not be divided, no? Why is it divided? Okay. So whenever A is related to B, then B is related to A. For all A comma B in A. Okay. For all the sets from A, now A is related to B means if A comma B belongs to R, then B comma A should be an element of R. Okay. If A is related to B, B should be related to A. Right. Similarly, a relation R on A is not symmetric if there exists at least one A comma B belongs to R, but B comma A does not belong to R. Okay. So here, did you get it? At least one element. If you want to, if you are able to find out that A comma B belongs to R, but B comma A does not belong to R, then we say that it is not symmetric. Got it? Any doubts in this? If A is related to B, then B should be related to A. That is a condition for symmetric. A is related to B, then B is related to A. For all A comma B in A. Okay, this is symmetric. Next is anti-symmetric. This is again very, very important. Try to understand this. Try to understand this because all these definitions are important for equivalence relation and partial order, right? So a relation, one definite question you can expect for either from equivalence relation or partial order. So a relation capital R on a set A is said to be anti-symmetric whenever A comma B and B comma A belongs to R, then A is equal to B. This is by definition. Please write this definition in the exam. But to understand this, if A comma B belongs to R, you cannot have B comma A in another different elements of A and B. You cannot have like this. Okay. So if A comma B and B comma A belongs to R, then A should be equal to B. This is the meaning. Okay. So wherever if there exists A comma B belongs to A such that A comma B and B comma A belong to R, A not equal to B, then R is not anti-symmetric. And again, as we have seen in reflexive and irreflexive, symmetric and anti-symmetric are not negative of each other. If it is not symmetric, it need not be anti-symmetric also. So anti-symmetric is different and not symmetric is different. Not symmetric means at least if you are able to find out for some Elements A comma B belongs to R. So for some element A will be related to B and B is not related to A. You can find out some element like that. So for some elements it will be there. But anti-symmetric means for no element of A, B, if A is related to B, B should not be related to A. If A comma B belongs to R, definitely B comma A should not be in R. Got it? This is the difference between not symmetric and anti-symmetric. Not symmetric means what? For some element A comma B is there, B comma A may be there. What is symmetric? A comma B is there, then B comma A should be there. It is for symmetric. Anti-symmetric means if A comma B is there, B comma A should not be there for every A comma B. Got it? This is the difference between symmetric and not symmetric and anti-symmetric. Again, I have given you one example where there are some relations which are neither symmetric nor anti-symmetric. Listen. Now 1 comma 3 and for 1 comma 3, 3 comma 1 is there. For 2 comma 3, 3 comma 2 is not there, therefore it is not symmetric. How will you find out whether it is symmetric or not? For every element A comma B, B comma A should be there in the set, in the relation. See 1 comma 3 is there, you have to check whether 3 comma 1 is there or not. Okay, yes, it is there. For this it is there, fine. 2 comma 3 is there, but 3 comma 2 is not there. See 2 comma 3 belongs to R, but 3 comma 2 does not belong to R. Therefore, it is not symmetric. This implies it is not symmetric. Because why it is not symmetric? Because 1 comma 3 and 3 comma 1 is there. Okay. Now, anti-symmetric means what? Even this should not exist. This should not be there. You are not supposed to have 3 comma 1. If 1 comma 3 is there, 3 comma 1 should not be there for anti-symmetric. Okay. See, all these definitions are important, very easy only if you concentrate. Okay. So, reflexive means what? A is related to A for all the elements of the set. Symmetric means what? If A is related to B, B should be related to A. Okay, that is symmetric. So, for not symmetry, anti-symmetric, if for some elements, if you have AB and BA, and for some element AB and BA is not there, then it is not symmetric. What is anti-symmetric? If you have A comma B in the relation, you are not supposed to have B comma A in the relation. That is anti-symmetric. Is it clear, all of you? Is it clear? Is it clear? Any doubts in this? Any doubts in this? And you can have some sets, some relations which are neither symmetric nor anti-symmetric also. Got it, all of you? Yes. Okay, very good. Thank you, Fatima. Yes, ma. We'll go to the next one. Yes. Clear. Very good. Super. Next is transitive. Next is transitive. So, a relation or on a set A is said to be. We have come across so many things. Yes. Okay. We'll do some more problems. Don't worry. When we do problems, it will be more clear. You will get more clarity in that. Okay. A relation or on a set A is said to be transitive if A is related to B and B is related to C, then A is related to C. Yes, AB and BA. Yes, correct. Exactly, Shrutika. Yes, ma'am. Anti-symmetric means if A is related to B, B should not be related to A. Lucky Royal. B should not be related to A. For every element, if A is related to B, B should not be there in A. Therefore, it is in that case, it is anti-symmetric. Okay. So, transitive means if R is a relation on a set A, always remember on a set means what? A to A. Always it is a subset of A cross A. Please remember that. Okay. A relation R on a set is said to be transitive if you have A is related to B and B is related to C, then A is related to C should be there. Similarly, that is in other words, you can say, yeah, okay. If A comma B and B comma C belong to R, then A comma C belong to R. Always I give this example, no? A is equal to B, and B is equal to C implies I can write this as A is equal to C, right? This is transitive relation. And in the previous classes, for even for the first unit, we have used this. All these things I have told you, transitive relation, remember transitive relation, I have explained this also in the previous classes, right? So, less than example, less than or equal to is transitive, sorry. A is less than or equal to B and B is less than or equal to C implies A is less than or equal to C. This is another example for transitive. Okay, even equal to is transitive. Got it? Clear now? So, now equivalence relation means, now till now what are all the definitions we have seen? Reflexive, irreflexive, symmetric, anti-symmetric and transitive. 5 definitions we have seen, right? Now, a relation or on a set, this is very important. One definite question you can expect from either equivalence relation or the next topic, partial relation. Okay. So, a relation R on a set is called equivalence relation if R is reflexive, symmetric and transitive. Reflexive, symmetric and transitive. This is very important. You have to remember this. Equivalence relation, then reflexive, symmetric and transitive. So, R is an equivalence relation if it has the following 3 properties. Reflexive means what? A is related to A. First condition is A is related to A for all A in the set A. Okay, that is reflexive condition. What is the condition for symmetric? If A is related to B, then B is related to A for all A comma B in capital A. Got it? Not symmetric means for one element, if it is not there, then it is not symmetric. Yeah, 1, 2, 1, 1, 2, 2, 3, 3, it is reflexive and symmetric, Bhavya. Ramakrishna, not symmetric means for even for one element, if it is, for example, I have given no. 1, 3, 3, 1 is there, but 2, 3, 3, 2 is not there. Then it is not symmetric. Okay. No, otherwise it is not symmetric. So if one, for one element at least A comma B is there, B comma A is not there, then it is not symmetric. Okay. So third condition is if A is related to B and B is related to C, then A is related to C for all A, B, C in the set A. In the set A. Got it? If A is related to B, A is related to A for all A, then it is reflexive. What is the condition for symmetric? If A is related to B, this is I am repeating because you can by heart now itself. You can study now itself. If A is related to B, then B is related to A for all A comma B in A. Actually, we are taking these elements from A. Okay. Then, if A is related to B and B is related to C, then A is related to C for all A comma B comma C from A. Okay. Any doubts in this? Tell me, I'll explain. This is equivalence relation. Equivalence relation. Yes. Very good evening, Gideon. Lomit, Abba. After a long time, no, Lomit, how are you? Not to be seen in the classes? Okay, next is, shall we go to the next topic? Yes, okay. Next is partial order relation. There is a small difference between equivalence relation and partial order relation. For partial order relation, a relation R is, what is condition for equivalence relation? Please remember these things. Reflexive, symmetric and transitive. For partial order relation, here it is reflexive. Again, a relation R on a set is called partial ordering or partial order relation. If R is reflexive, anti-symmetric and transitive. So, the difference between equivalence relation and partial ordering is the second one. Second one. Okay. Yeah, I am fine, Lomit. Okay, no problem now. I am able to conduct at least 1 hour class. Yes. Equivalence relation, we will do definitely problems. We will do definitely problems, ma, don't worry. So reflexive, antisymmetric and transitive. So for equivalence relation, we have reflexive, symmetric and transitive. For partial ordering, the difference is in the second one. Second one should be antisymmetric. If it is reflexive, antisymmetric and transitive, then we will say that it is partial order relation or partial ordering. So R is a partial order relation on A if it has the following properties. Can you tell me the properties now? Reflexive means what? A is related to A for all A in the set A because R is defined on A. Okay. Second one is if A is related to B and B is related to A, then A should be equal to B for all A comma B in A. This is the definition for antisymmetric. To understand that, I have told you if A is related to B, B should not be related to A. To check, you can use that. But if you want to write the definition, if A is related to B and B is related to A, it is possible only when they are equal. That means if A is related to B, B is related to A should not be there. Okay. And third one, third condition already we have seen. If A is related to B and B is related to C, then A is related to C. For all A, B, C belongs to capital A. Okay. So these are the conditions in partial ordering. There is a small difference between equivalence relation and partial ordering. Equivalence relation is reflexive, symmetric and transitive. Partial order relation is reflexive, antisymmetric and transitive. Okay. Any doubts? Shall we go to the next topic? Partially ordered set. Next is partially ordered set. A set together with the partial order relation. If you can find out in a set, if you can define one partial order relation, then the set is called partial ordered set or poset. Partial ordered set or poset. Okay. For example, if you consider the relation greater than or equal to defined on the set of integers. Z is the set of integers. Set of integers, then for all A comma B in the set A ma, for it is not A, capital A, capital A. Yeah, example definitely I'll do problems, don't worry, Lucky Royal. I'll do problems. Okay. Greater than or equal to and Z. If you define the relation greater than or equal to in the set of integers, I am giving example for this. So is it reflexive? Can you say that greater than or equal to is reflexive? Can you say that A is greater than or equal to A for all A belongs to the set Z on which it is defined? The relation R is defined as the relation greater than or equal to on the set Z. That is R is a subset of Z cross Z. Isn't it? Now, can you say that is it true? The first condition. For partial order, you have to prove that it is reflexive, antisymmetric and transitive, right? Is it true? First one, is it true? Can you say that A is greater than or equal to A for all A belongs to Z? Now, if A is greater than or equal to B, and B is greater than or equal to A. Then what? When is it possible? When is it possible? You have to take for everything, you have to take for all ma. It should satisfy for all the elements on the set. In which set, from whatever set we are defining, whatever set we are taking the elements, it should satisfy for all the elements. Okay, you cannot escape from any element also. It should be, you should be able to define for all the sets. Yes, if A is greater than or equal to B and B is greater than or equal to A, can anyone tell? First one is true. Is it true? I didn't get answer for even first one also. Are you able to follow or not? Can you say that A is greater than or equal to A for all A in the set of integers Z? Sorry. Can you say that A is greater than or equal to A or not? Say yes or no. Is it reflexive? Is it reflexive? Yes or no? Okay, it is reflexive. It is true for all A is greater than or equal to A. In every element you can say that it is greater than or equal to A. Yes, okay. So it is reflexive. What is the answer for this one? Second one. A is greater than or equal to B and B is greater than or equal to A. When is it possible? When is it possible? See, 5 greater than 3, you cannot write 3 greater than 5, right? Got it? You cannot write, this is not possible, right? So when it is equal, then only it is possible. This equal to only will be able to, yes, where only this equal to is possible, right? Yes? Is it clear or not? When is it possible? When they are equal. A is equal to B. A is equal to B. Then only it is possible. A is equal to B. Yes, very good. Anvesh. Hi Anvesh. Very good evening, ma. Even I am seeing you after long time. How are you? Yeah, when A is equal to B. Mohan, correct. Excellent, excellent, excellent. Very good. Yes, next one, third condition. Third condition. If A is greater than or equal to B and B is greater than or equal to C, what can you say? What is the conclusion? What is the conclusion? What is the conclusion? A is greater than or equal to B and B is greater than or equal to C. Then, Shravan Kumar, good evening, ma. Yes? Please give the answer, no, ma. A is greater than or equal to B and B is greater than or equal to C is possible only when? Then, if both are satisfied. Transitive. Yes, it is transitive. Yes, very good. Lomit. Yes, ma. A greater than or equal to C. Yes, correct. Shrutika. Yes, correct. Very good. A greater than or equal to C. That means A greater than or equal to C. All of you got it? Yes. They are not equal, Shravan Kumar. It is greater than or equal to. Second one, it is possible because we are inverting the elements, right? So it is possible only when they are equal. But this is A greater than or equal to B. See, if you take 10 which is greater than 7 and it is, and you know that 7 is greater than 5, then 10 greater than 5, right? So you can have, you need not be equal here, but equal if 5 is greater than 3 and 3 you cannot write greater than 5. That is why equal to, it is only, it holds good only for equal to. Okay, that is why they need not be equal. Even Shravani, A need not be equal to C, ma, greater than or equal to C, greater than or equal to C. Now Lucky Rai, Vesma correct, Mohan correct, Bhavya correct. All of you understood, right? Shivakumar, right? Shravani, it is greater than or equal to. Okay, it need not be equal to again. Once again, need not be equal to alone, right? Yes. Then Shivakumar, yeah, it is transitive. Yeah. Second one is symmetric. Yes, it is not symmetric, ma. It is anti-symmetric. Here it is anti-symmetric. Here it is anti-symmetry. Okay. And here again, for all A comma B, you have to write for all A comma B in the set A. Here for all A comma B comma C from A, therefore it is transitive. So it is satisfying all the three conditions, therefore it is partial order relation. Hi Anvesh, yes ma, okay, yeah, very good. Even I am good. I have recovered, yes. So next is equivalence class. It is not that important, but you should know, you should have some idea about that class. Notes I'll try to upload, ma. Shravan, I'll upload the notes, okay. I have to make it as PDF, and the PDF I'll try to give you. Give me some time, 2 or 3 days time, I'll do that, okay. I was busy in that question paper also I had to solve, and I have to prepare these things. That's why I couldn't find time, okay. I'll give you notes, even somebody else also asked. I'll give you. PDF I have to make it and I'll give. Okay. Next is equivalence class. Very simple only. Very easy. See, consider the elements which are all related. It is denoted by equivalence class. Now we have seen some elements, right? PDF I'll tell you. After uploading, I'll give you the link. You can, when you click the link, you can get the PDF. I have not yet uploaded now. Okay, I'll upload and give you the link. From that you can go through, right? Yes. So here if you consider any element A, okay, consider any element from that set, and what are all the elements which are related to this A? If you consider those elements, that is called the equivalence class. Similarly, for all the sets, for all the elements, you can find out that you can find out the equivalence class. If you consider for every element, if you are able to find out equivalence class, if you put together all those elements, that is called the quotient set. Okay. Okay. Yes. Okay. Okay, ma. Okay. So here quotient set means you have to consider all the equivalence classes. For all the elements, if you find out these equivalence classes, all the equivalence classes put together will give you quotient set. Okay. Yes. So example, A is equal to 1, 2, 3 and define. This is an example. So R is equal to 1, 1, to 1, 2, 2, 1. This is the relation we are defining on the set A. Okay. There is no WhatsApp group, a Telegram group. I have to create now. I'll see whether I can manage that or not. That I have to see. I'll see. If possible, I'll start. Okay, one group for those things. Right? I'll try. Like Kirail and Shravan. No such group till now. Okay. So define this R as a relation as 1, 1, 1, 2, 2, 1, 2, 2, 3, 3. Now we have to find out. It is an equivalence relation. Now forget about partial order. Now we are talking about equivalence relation. Equivalence relation means it should be reflexive, symmetric and transitive. Yes, it will. You can check these conditions. Okay. And now R is an equivalence relation for this. Now what are all the elements here? In the set A we have 1, 2, 3. So what is the equivalence class for 1? How will you find out? What are all the elements related to 1? See, 1 is related to 1, 1 is related to 2. That is, this 1 is related to 1 and here 2 is related to 1. So for 1, along with 1, what are all the elements related? So 1, 2. This 1 and 2. Okay. From this you can write what are all the elements which are related to 1. So 1, 2. This is called the equivalence class for 1. Equivalence class for 1. Okay. Now for 2, what are the elements related to that? For 2, it is 1 is related, again 2 is related. 1 is related and 2 is related. So these are all the elements which are related to 2. So they will give you the set equivalence class for 2. Okay. And for equivalence class for 3, which are all the elements? 3, 3, only 3. So it is only 3. Only 3. Okay. So equivalence class of 1 is 1 comma 2, which are all the elements related to this element. They will give you the, if you write them in a set, that gives you a equivalence class. Okay. And if you write A given R, see, A is a set, A is the set, and on A, R is a relation, R is a relation defined on A, defined on the set A. Okay. And A given R or A by R, this is A by R, we read it as A by R is the quotient set of A with respect to the relation R is the set of all equivalence classes. How many sets are there? How many elements are there in that? 1, 2 and 3. Equivalence class for 1, equivalence class for 2, equivalence class for 3. These are all again subsets. Okay. Now we'll do some problems. I'll give you some more problems on that. I'll give you the relation, you find out. Okay. Right, the relation capital R on a set, capital R on a set A is equal to 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 is defined by the rule, is defined by the rule A comma B belongs to R if 3 divides A minus B. 3 divides A minus B. Similar question was asked in the previous DM exam, which was on Saturday. And I have told you for your information, I have uploaded the question paper in the, I have posted in post community, and I have uploaded the answers also. Okay, that video is there in the channel, you can go through, right? So A is equal to 1, 2, 3, 4, 5 is defined by the rule A comma B belongs to R if 3 divides A comma B. Similar question, A comma B comma A is equal to the set X is equal to the set 1, 2, 3, 4, 5, 6, 7 they have given, and A minus B is a multiple of 3. That was the question asked in the Saturday's paper. Okay. Now this is the relation. What is the question now? List the elements of R and R inverse. The first part. First you do this. First part, list the elements of R and R inverse. List the elements of R and R inverse. For that, you have to write A cross A first. Always remember, it is R is a relation on a set means, yeah, it is a subset of A cross A. Definitely, it is a subset of A cross A. Yes, ma. Okay, A cross A is equal to Shravan Kumar. I am giving the important topics only. Okay, you can expect questions from these topics. You attend all the classes, live classes, you can get. You can go clear. So A cross A is what? You write the sets 1 comma 1, 1 comma 2, 1 comma 3 and so on, 1 comma 5. I'll write that also. Why to leave 1 comma 4 and 1 comma 5, right? Similarly, 2 comma 1, 2 comma 2, etc. and 5 comma 1, 5 2, 5 3, 5 4 and 5 5. These are the sets, right? For live classes, every night 8 o'clock, 8 p.m. Okay, every day. So now A cross, this is our A cross A, from which we are going to choose elements of R. What is the condition for now we are going to find out a subset from this A cross A which satisfies our condition. What is the condition? If 3 divides A minus B, then we say that A is related to B. Okay. That's what I'm telling Shrutika. Please listen carefully when I'm explaining. Please listen carefully. A cross A, all R is always a subset of A cross A. Okay. A cross A is the Cartesian product. Always the relation is a subset of the Cartesian product. Okay. Now, what are all the elements which can be there in R, R? Anyone can say? Yeah, it is a subset. Yes, of course. Will you include 1, 1 in R? Actually, 3 divides A minus B means A minus B is a multiple of 3. You can say A minus B is a multiple of 3. Yes, it is a binary relation. That's why. Yes, ma. Okay. Yeah, for Akanksha, he is giving. Yes. Yes. It is not on to Shivakumar. It is function there. Yeah. See, A cross A is the set. It contains all the possible ordered pairs. If you write all the possible ordered pairs, then it will give you Cartesian product. If there is relation between A and B, you have any restriction for A and B to have the relationship, then it will come under R. Okay. Now, yes, 1, 1. Wait. 1, what is 1, 4 then? Is it an element or not? 1, 2 will not be there because 1 minus 2 is minus 1. It is not there in, it is not a multiple of 3. Therefore, it will not be there. What about 1, 3 will not be there. What about 1, 4? Yes, it is a multiple, right? 1, 4 is also there. Yes. Okay. 1, 4. Then 1, 5 will not be there. What about 2, 1? No. 2, 2? No. 2, 3? 2, 4. 2, 3. 2, 2 will be there. 0, right? Yes, ma. And A, 1, 1 is 1, 4, 2, 2. Write all the elements now. Write all the elements like this. Check and write all the elements. One, 1, 4. Yes, ma. Please put them in the brackets, okay, properly. Yeah. Join and meet of matrices, okay. Yes, Bhavya, very good. Thank you. Nice. Good. Join means union, meet means. And in the representation, we will see that, Akanksha. Don't worry. In the matrices, representation, we will see. Join and meet, okay. Yes. 1, 1, 1, 4, 2, 2. What are all the elements? Please list out the elements in R. What will be the next element? 2, 5, right? Have you completed? I'll write, you please check whether you have written correctly or not. Then 3, 3. Next 4, 1, sorry. 4, 1. 4, 4. You have to check in between any elements. If it is left out, tell me. 2, 4 will not be there, Shrutika. 5, 2. Next element will be 5, 2. Then 5, 5. Yes, 1, 1, 1, 4. How many are there? 1, 2, 3, 4, 5. 9 elements are there. Yes. Mohan, correct. Excellent. Yes, very good. Very good. This is our R. This is our R. R is the relation. A is related to R if 3 divides A minus B. Find the difference between A and B. If it divides, if it is a 3 divides means what? It is a multiple of 3. A minus B should be a multiple of 3. If it is a multiple, then include in R. 1 minus 1, 0. You can write 3 into 0 is 0. So you can write 1 minus 4 is minus 3. It is a multiple of 3. So you have to include. Yeah, that's what I am doing, Akanksha also. 2 comma 2, it is 2 minus 2, 0 is a multiple of 3, so we have to include. 2 minus 5 minus 3, it is a multiple of 3. 3 minus 3, 0. 4 comma 1, 4 minus 1 is 3, it is a multiple of 3. 4 minus 4, 0 is a multiple of 3. 5 minus 2 is 3, is a multiple of 3. 5 minus 5, 0, it is also a multiple of 3. So, except this, no other element. I think I have not left any element. Okay. Yes. R divides, it is not R divides A minus B. R is an, you have to write the elements A comma B in R. If you can write A is related to B, if A minus B is equal to 3 into something. It is a multiple of 3. Okay. So when will you say that A is related? Now 1 and 4 are related. 1 minus 4 is equal to minus 3. It is a multiple of 3. So 1 comma 4 will be there in R. Like this. Got it? Yes. Now what is R inverse? R is the set. This is the set. Here itself we can write R inverse. Did you understand this or not? It is a multi. If it is a multiple of 3, then we can include in that. Okay. What is R values? See, both are defined from capital A. Always remember, that's what I'm repeating so many times. On a set means, that means you are not at all listening. See here, R on a set A. On a set means 3-4 times I have told this itself. See, R on a set means R is from A to A. That is, R is a subset of A cross A. R is a subset of A cross A. That's what I'm telling. Both the elements you have to take from A only. B means, it does not mean that it has to be from the set B. From A only I am taking. I am taking the element 1 from A, and this one is also from A only. And 1 comma 4 means 1 is from A and 4 is also from A. Got it? Yes? Yes or no? This is our R. Now when you write R, R inverse will be very easy. What is R inverse? You just have to reverse this value. So 1 comma 1, again 4 comma 1, then 2 comma 2, 5 comma 2, 3 comma 3, 1 comma 4, 4 comma 4, 2 comma 5, then 5 comma 5. You will get the same of course, but need not be always the same. R and R inverse need not be the same always. Okay. Now you can prove that R is a symmetric equivalence relation or not. Find whether R is an equivalence relation or not. Let me write R once again. R is equal to, A is the set 1, 2, 3, 4, 5. Okay. Now R is the relation. We have defined it to be 1 comma 1, 1 comma 4, 1 comma 1, 1 comma 4, 2 comma 2, 2, 2, 2, 5, 3, 3, 4, 1, 4, 1, then 4, 4, 5 2, then 5 5, right? According to the given condition, this is our 1 comma 1. This is our R. Now you have to prove that, check whether it is an equivalence relation or not. Sagar, yes ma. We get R inverse. Yes, just reverse the elements. That's all. Very simple. Okay. Okay. Iram, I'll give you a PDF. Don't worry, I'll give you. Okay. So now you have to check whether it is a equivalence relation or not. One is related to, now how many elements are there in A? 1, 2, 3, 4, 5, right? One is related to 1. Yes, 1 comma 1 is there. 2 comma 2, yes, it is there. 3 comma 3 is there. 4 comma 4 is there. 5 comma 5 is there. Therefore, all the elements are related to themselves. Therefore, it is R is reflexive. You can write that for all the elements A, or you can say that A is related to A for all A in capital A. Okay, that is the first condition. Therefore, R is reflexive. Therefore, R is reflexive. And this is the first condition we have proved. What is the second condition you have to prove? A is related to B. If A is related to B, then B should be related to A. Let us check for all A comma B in R. I am writing because I know it is reflexive. See, 1 comma 1, 1 comma 1. 1 comma 4, then 4 comma 1 should be there. Is it there? Yes. 1 comma 4, 4 comma 1 should be there. It is available. Okay. 2 comma 2, yes, it is reflexive. It is symmetric. 2 comma 5, then 5 comma 2 should be there. Similarly, 3 comma 3, 4 comma 4, 5 comma. Is it symmetric? Yes, it is symmetric. It is satisfying this condition. Therefore, R is symmetric. R is symmetric. Okay. And third one, if A is related to 1 is related to 1 and 1 is related to 4. See, you have 1 comma 1 and 1 comma 4. And transitive means you must have 1 comma 4. Yes, 1 comma 4 is already there. Okay. And yes, 1 comma 4 if you consider, and 4 comma 1 if you consider. 4 comma 1 and 1 comma 4 and 4 comma 1. 1 comma 1 should be there. I'll write it again here. 1 4 and 4 1. If they are there, you must have 1 comma 1. Is it available? Yes, it is available here. Okay. Similarly, you can check for everything. Any element if you take, definitely it will satisfy this condition. So, if A is related to B and B is related to C, then A is related to C from the table itself. From R we can find out. You can write. It is obvious. Okay. Here I told no, A minus B divides. Shivakumar, you did not listen to this. A minus B should be multiple of 3. See, 4 minus 1 I have explained, no, 4 minus 1 is 3. You go through that video again, you will understand, okay. So, A is related to B and B is related to C, then A is related to C for all A comma B comma C in A, from the set A. Okay. Therefore, R is transitive. R is transitive and hence R is an equivalence relation. R is an equivalence relation. Yes, ma. For all sets in A cross A. Yes. Yes, okay. Condition R is not a set, Akanksha. Don't get confused. See, R on a set A. R is a relation on a set A. It is a subset of A cross A. Don't get confused. Don't get confused. Or is a relation. Relation means it will contain ordered pairs on a set. Which set? A is a set. On A means what? A cross A. It will be a subset of A cross A. It is also like subset only. Okay. It is, sorry, it is also like function only. A cross A. Got it? Yes. So it is an equivalence relation. We'll stop here. Okay, understood. Yes, ma'am. Actually, I thought of doing that some more. We'll see in the next class. Has diagram, I'll tell you in the next class. Okay, I'll teach you in the next class. If you till now whatever we have studied, if you have any doubts, you can ask. Otherwise, we'll wind up. If you have any doubt, any doubts? Okay, ma, no problem. You can go through the video again. Still, if you get any doubt, post your doubts. I'll clear. Okay. In the next class. In the next class. Okay. You once again you go through. I have given enough examples to make it clear. If you still have any doubt, I will clear in the next class. Okay. Okay. Yeah, I will provide notes, ma. Vineet. Yes. Okay. Thank you. Good night.